Hi. Um, Thanks for coming to my talk. So today I would like to speak with you about the machine learning and mobile and how to make it work together. Um, First thing is we would need to ask ourselves a question: do we really need machine learning on the phone? Because if we don't, well, why bother? So I thought about it, and there are some things at which the machine learning is really good. It's even better than humans. So, for example, in image recognition, in some games, in voice generation and recognition, there are apps which make our world better and use machine learning. For example, there is quite recently published an app which makes transcription of the surrounding environment for people with some hearing difficulties, and of course, just voice transcription can be handy if you do like a voice note. So for the tasks that we need, and the best solution is machine learning, we should use it. Therefore, I would argue that we need machine learning. So if we need it, let's think about how can we implement it on the phone. Well, first idea, we could use the server side to do machine learning for us. So the inference, I don't know how, if you know the term inference, but basically it means the part or the part of the lifetime of the model when you don't change anything in it. You just make use of the model you trained and you get predictions. So we could do machine learning on the server and feed the prediction to the phone. Okay, but it may have some problems, and it surely has some benefits. So I would like to ask you. You can just shout or tell me. What do you think the benefits of this model would be? Do you have any idea? Awesome, computing power. That's true. That's the first thing. Um, yeah. Okay. Okay. Model is a black box on client. That's true. Yes. That's awesome. Exactly. We have precise control over the model. We can change it easily. Anything else? Monitoring. Surely. Yes. Okay. These are the stuff I came up with. So the control, we can change the technology stack quite easily. We want to use PyTorch, no problem. We want to use TensorFlow, no problem. We can use Java or whatever the framework comes up. Cheap computing power, yes, and a power source, of course, because well, no problems with power when you have a server connected to the electrical power supply. Okay, so to quote scientists from the show The Big Bang Theory, uh, I would use machine learning on the server if I could, but I can't, so I shan't. And again, could you think of any problems with the machine learning on server which would make the whole solution well, either obsolete or bad for us? Latency, exactly. If you have a model for example, predicting the screen orientation, if you switch your phone and have to wait like 3 seconds for it to change orientation, it will be bad. So first thing, latency. Awesome, availability, exactly. So our clients are guys who drive around the country for very long hours, and sometimes they just don't have the internet connection. So exactly the availability. Anything else? Once again, maintain. Yes. Exactly. The cost of the servers. Sure. Data privacy, yes, that's very important, especially like in this year we had the whole thing with Rodo, and sometimes you just don't want to send your data to the server. For example, we have right now we have keyboards that learn our patterns. But sometimes we type in passwords. We wouldn't like our passwords to go to the server, yeah, right? So yeah. So basically, I came up with exactly the things you said. I also added the cost of the bandwidth because you have data plan. In Poland, it's rather cheap to have like many gigabytes of data plan, but possibly, in other words, in other parts of the world, it's not that cheap. Okay, so we have another option. Another option is to put everything on the phone. Okay, same thing. So we have like model training, we have inference on the phone. We don't have the problem with latency, but we have, okay, well, okay, why not? I'll ask you again. I promise it's one of the last times I ask you. What would you point out as the drawback of doing machine learning on the phone? Exactly, computing power. Phones are getting better and better, but still they're not as good as servers. First thing. Yeah, different models of phones, exactly. So we don't have the same architecture. It might be a problem because well, some of the users may have top quality phones, some not. True, that's true. Huh? Battery life, exactly. The training of the model is very costly, well, time-wise and resource-wise. So we would kill the battery of the phone. Sharing results? Yes, that's true. We would have to make create a sort of infrastructure for publishing the results. Okay, so basically, I came up again with the same things you suggested. I also added limited tools and functionalities since machine learning on the phone is still in a very early age, so we can't use everything on the phone. Okay, so I would suggest to use a hybrid. So we would make the inference still on the phone, so we don't have problems with latency. We don't have, well, we might have problems with privacy, but if we propagate the information to the server in a correct manner, that's also might not be an issue. Google does that with the example I mentioned before with a keyboard. So it just computes the gradient on the phone and then sends it to backend to update models. So the training takes place on the server where we have power supply, where we have computing power, and which is cheap, and also we have control over it. Okay, so how do we do that? Google some years ago made a framework called TensorFlow, and I think the TensorFlow was released in 2015, and the first works well published around 2011, and then it was called Disbelief. But in 2017 they announced something called TensorFlow Lite. So it's a framework designed specifically for mobile devices, and it allows you to create a model in TensorFlow and convert it to a version which is compatible with the mobile device. Okay, unfortunately, it doesn't support everything. So this is just an extract from their webpage. So there are some operations which are fully supported, some which are conditional, so as long as something, and some aren't supported at all. For example, recurrent networks and specifically LSTMs are not supported. If you would like to check exactly the operations you need, there is a web page with the exhaustive list of things that are supported and not supported. Okay, as I've said, the architecture looks like this. So you prepare a model with TensorFlow, but having in mind that not all the operations are supported. Then you convert it. When we prepared our models, it was called the Toko converter. Right now, it's called the TensorFlow Lite converter, and the output of the converter is a TF Lite file, which then can be deployed to the phone. There the interpreter takes care of running it and getting the output for us. Okay, that's cool, but models can be big. I mean, like can take much of the disk space, and also there are sort of suited more for servers. So TF Lite does one cool thing, which is quantization. Basically, TensorFlow works on the on float files, float variables, which are 32 bits long, and the model quantization allows for cutting it down to 8 bits. Okay, what's the output for us? First, less bits in arithmetic. It's faster to make the computation. Less memory consumption, 4 times less memory. We need 4 times less memory for the weights, for example. Less memory access calls. If the variables are smaller, we can fetch more in one call. Also, if your device, your edge device, supports only integer operations, TensorFlow allows also for that. So it converts to not 8 bits float, but to 8 bits integer if we so require. And also there is an option for quantization-aware training. So we can incorporate some functions into the training process to get even more optimization. And to put some data on the screen, these are also from their website. Information how is the optimization doing. So we can see that we get some of the accuracy loss. If we do accuracy, if we do quantization aware training, the loss is smaller. But even the basic one gives us quite a gain in both latency. Well, loss in latency, but gain for us. And also look at the size of the model. It's like 4 times smaller. Okay, but okay, we got through the phase when we understand how to convert it, or at least we know that it's possible to convert it to a mobile supported version. So how do we put it on the phone? We just need basically to load the model. Well, send the model to the phone, save it on the storage, and load it with the interpreter with data preprocessed by our functions. To make it up to date, we can create a flow to send a new model each time we have a new labels or updated labels for our model. So okay, right now we're somewhere halfway through my talk. So to summarize, okay, we have some tasks that we need machine learning for. There are some reasons to, well, quite a few reasons, I would argue even, to do the inference on the phone, like latency, like privacy. We can use a library which is well accepted and broadly used, which is TensorFlow, and we need to only be aware of the changes we need to make in so that it will be compatible with mobile device, and we can switch or change models. Okay, so this was theory. Right now I would like to get into how at Edward.ai we used TensorFlow Lite to perform machine learning on the phone. So first thing, what do we do at Edward.ai? Because the context is important. We make a set of tools and set of solutions for salespersons. And we call this set Edward. Edward, your assistant. It is important because, firstly, we have quite a lot of sources of data. We have emails, we have phone calls, we have notes, we have calendar with all of the meetings and all of the relationships with your clients. And also, it's important because many of our clients are very mobile. So they have their clients all around the country. They need to drive to them. They need to go to the meetings. So sometimes it's not possible to have a stable internet connection. And therefore, our mindset is offline first. So our applications and our solutions must work on the phone. Therefore, machine learning on the phone is exactly what we are looking for. Our use case, and this is the use case I'll go through today to show you how we worked on with TensorFlow Lite. Okay, so if you go to conferences, or even maybe on Spirit, you will get lots of those, which are business cards. Business cards contain some of the contact information from somebody that you talked with. And sometimes you don't have time to work with it, so you just put it in your pocket, and find it week, 2 weeks, a month later, hopefully intact, because possibly you did some laundry, and the business card looks like a paper mesh. Also, if you would get a business card from somebody, you couldn't just say, sorry, I need to type that in, and spend 40 seconds or a minute typing in somebody's name, somebody's surname, phone number, email, and so on. And I know it especially because my surname is very long, and I always had problems with typing in time. So, yeah, we would need a solution to allow you, for example, on the conference, to just look at the business card and get the information into your phone. So yeah, it could look like this. So photo, hopefully, because photo is really fast to take. Photo on the left, and output would be some sort of structure with contact details. Okay, so I used my CTO business card because I don't have mine, and I also wiped out his contact info just in case. And what this photo can tell us? Okay, so we have his name and surname. We have company name. We have job title. We can see it was a phone number, and also here you have to trust me, there was an email address. So we have a part of information which basically we don't have to process. We have to just tag them correctly. Okay, so this would be the sub-functionalities we would require. Firstly, take a photo. We won't talk about it because it's just a functionality you get by buying the phone right now. Conversion from image to text. It is done by a model, but we were sort of lazy, or we just use the solution which is good and which is provided by Google. We have an offline model that converts the image to text. Classifying text. Okay, this will be the task we will be talking about today. Saving contact. Simple. We just need to save the extracted information correctly to the phone, and ability to improve predictions over time. So basically, it's what I talked earlier, which is to switch the model for a new one when you have additional data. Okay, so let's go to the text classifying. Okay, so this would be the requirements I came up with. So we have classes, because we don't need to exactly understand what the information is about. We need to know what kind of information is it. So we would have some first name and last name, so it's some name information, email address, job title, and organization of the person that gave us the business card. And also, I think I missed, but also the phone number, obviously. Another requirement is about the storage and CPU and RAM usage. So we are using phone, and we can't be sure what kind of phone we are using. One of you suggested that we have different kind of phones, and we can't just say, excuse me, you can use our app, but if you will buy the newest Samsung, iPhone, whatever. And also, there can be some typos in the text we will receive, because, well, the module that is responsible for converting image to text is also a model. Sometimes it makes errors, and we find out the hard way, because in Polish we have a letter E, which basically looks like a T, and model thought it was a T quite a lot of times. Okay, so if we need to process text, let's think how humans process text. And at least it's in schools, we are taught to go sequentially from, in Polish or in English, from left to right. It could be from right to left, up, down, whatever. But we go sequentially, letter by letter, then word by word, sentence by sentence, paragraph by paragraph, and so on. Okay, so if we could use this as a sort of guideline for what kind of machine learning algorithm we can use, we would think of RNNs. This one is an LSTM. So LSTMs or RNNs are just networks which have a sort of loop, and they remember state. So if you feed them more data, they will have some sort of connection with the previous state, and that's exactly what we're looking for. So we fed it lorem, then fed it ipsum, and so on and so on. Hopefully, we will get a result. For us, it won't be word by word, by more character by character. We used n-grams, which is basically a bunch of letters in one bucket. So we could use LO, then OR, then RE, EM, and so on. Because what we need to classify is not sentences, but words. Words consist of letters. Bunch of letters is an n-gram. Easy enough. Okay, but can we use RNNs or LSTMs? As I mentioned before, unfortunately, Tensorflow Lite doesn't support it. So it was quite annoying information for us when we find out that in documentation, and the guy who came up with the RNN solution was infuriated, because he spent quite a lot of time in making the model and making really, really good. So we came back where we started, and we thought, okay, how do we read? So if you went to some sort of course, because there are some courses of fast reading, and during that course you learn that you can look at the whole part of page and understand the whole information. And therefore you're reading faster because you can process more data at one moment. So what if we do the same with our task? Because, well, we could try to find a solution which looks at the whole sentence, let's say more like 2 or 3 words at the same time. And is there such a network? Luckily, there is, and it's called CNN, which is convolutional neural networks. So the idea here is to split the text into those n-grams I mentioned before, encode those n-grams in either one-hot encoding, or we used counters. So we just get a vectorized representation of the n-gram. There is also some additional data because, for example, my name is Adam, but there is also word adamant, let's say. And my name starts with a capital letter. It is an important information, but also the important information is that adamant and Adam starts in the same manner. So we moved all of the additional context data to the end of the vector with a specialized part called context vector, and we normalized the text itself. So Adam and adamant would have exactly the same n-grams, and the first part of the vector would be exactly the same, but the context data would be a bit different, and the whole vectors were fed into the network. And well, strangely enough, it did work. I think I have a photo of how it looks, but it's a bit further. Okay. So we got a algorithm or a solution that works. It incorporates the whole data as we want it. It's not an RNN, but still gives us the result. Okay. How do we deploy it? So it's a bit similar to the diagrams before. So we feed phone with photos of the business cards. The results or the predictions are sent to the database. Then we have a labeling phase, which right now, unfortunately, is made by hand. This labeling triggers retraining of the model, and model is sent to the phone. This is how the labeling data looks. Okay. So we needed a specialized tool for that because quite a lot of business cards were photographed by our users. So this is well, it's easy to see what's going on. So we have a data on the left. We have a model type in the middle, and we have a status of the sample. Okay, on the right we would, okay, so here's label. We can label samples as a phone number, job title, address, name, etc., and also undefined, because sometimes on the business card we'll find additional data which would, if assigned to the wrong class, would destroy our model. Okay, so more about the deployment process, because I went around it up until now, but it's not that easy to run a model on mobile. Why? Well, we have a different architecture, and we want to have the same result for the same input. So to receive this result, we need to have the same pre-processing both on mobile and on server. And we achieve that by the left part stays the same as before. So we have a model in Tensorflow Lite. We convert it TensorFlow. We convert it to Tensorflow Lite. We have a model in flat buffer, which is a format that well is as lightweight as it gets. So and is interpreted by the TensorFlow Lite interpreter on the mobile. And also we have a config file, and it's important because it contains all of the information required to perform the pre-processing. So it would have dictionaries of data that we will need, how to interpret the output of the model, and also the name of the model. So if we would like to change it, we know which one on the phone should be replaced. And handling of this is implemented in Java. Unfortunately, that means that if we would like to add a new type of pair processing, we need to also implement it on the phone. Right now, there is no other way than have it implemented both on server and on mobile. Okay, so if we remember my CTO's business card, that's the output we would get on the phone. So there are pictograms which are assigned to each class. On the left, we have 2040IO, which is the name of the company, and strangely enough, it is assigned to the class of organization. There is a motto at the bottom. We didn't have any class for classifying mottos, but all of the information on the right is also correctly assigned. If you would like to see how it works live, I would advise you to download our app or become our client. Okay, but basically what it shows is that it is possible to perform machine learning on the phone with TensorFlow Lite model. Okay, so quick info about the roadmap or about what's going to change. So I've also added a link to their roadmap, so you can check which functionalities will be implemented even if in 2019, and they promise that the support of RNNs and LSTMs will happen this year. So I assume that means that most of the core functionalities of the TensorFlow will be available on TensorFlow Lite. Okay, so if you do make models in this library, that's a cool info. Okay, I think that's the end of my talk. And if you have any questions, I will gladly answer. Thank you.
Thanks a lot, indeed. When I was looking at the slide, I didn't actually see any questions. Let us check again. Maybe
Okay.
you can actually switch to that, or
I don't have this app.
we cannot.
Or
Okay, we cannot. Okay, so I'll check, and in the meantime, maybe there's just some live questions from the audience. Okay. I'll pass you the mic.
So if I understand correctly, as an input for your neural network was whole text on the card, yeah? As an output was just a label, yeah?
Okay.
Because it's a little bit confused.
Okay. Sorry. Yeah, I should have made it more clear. No. The input for the model is okay. Maybe I'll go. Okay. So the input for the model would be one line of text. For example, one line would be CTO and co-founder. Okay, and then the output would be a multi-label of classes. So the predictive model would tell us if it's either company or phone number and so on and so forth. And it's a binary classification, so only one of the there's no way that we will get multiple classes.
Okay, thank you.
Yes. Well. Okay. So you cannot correct per se, but we can see which kind of which of the information we labeled user is using to create a contact. So if you have marked data like this, you can just click on one of those buttons and click X to delete the label. And then if you click the create contact button, it won't use this information. And then the result of this user, let's say, correcting labels is sent to the backend, and here it's used as a label. So if we predicted phone number and user used this label to create contact, it will be here like this. And if he deleted this information, it will be undefined.
I actually have a question. How easy would it be to actually scale it to do recognition of multiple business cards simultaneously? So you have 10 business cards.
Yes.
And you take a picture of that, and you want to analyze all of that.
Ah, okay. We didn't check this use case. It should work because we work line by line. I would be a bit afraid to do that because I'm not sure how the Android application would react to having 10 phones or 10 names. But as of the model, it should work fine.
What's the inference speed on the, let's say, medium-end device?
I won't have data like in milliseconds.
Is it 2 seconds? Is it
No. It's like this. Because, well, it's fast enough that we didn't optimize it more or didn't measure it, because it's good enough.
All right, anybody else?
How many samples do you use to train this network?
Yeah, it's in hundreds, so it's not very, very much. Because unfortunately, the hundreds is the number we could put our hands on. It's not that easy to get somebody business card. You can just walk to somebody and can you give me your business card because I need it for machine learning. Yeah, but hundreds, which means on each sample we have up to 5-6 lines, so around 1,000, I would say. Yeah.
Okay. Anybody else? No? Okay, in that case, I think we should thank Adam again. Thank you very much.
Thank you.